So now let's talk a little bit more about elements and compounds. Remember, I told you guys that pure substances could either be elements or compounds. Pure substances cannot be separated by physical means. Elements can't be separated at all, physical or chemical, but compounds can be separated, broken down by chemical means. All right, there are 118 elements. 88 of them are naturally occurring, and 30 of them are man-made. The periodic table, that is going to be your absolute best friend this semester, has all 118 elements. Here we go. I don't know if you can see this really well. You might want to print out a periodic table. This is the one that your book has in the front cover, but you know, you can get it from anywhere. You will notice on the periodic table that it has all 118 elements. There is a symbol for each element, and that's called the atomic symbol. We're going to talk, oh great, hold on one second. I will turn this off. Okay, there we go. Who has home phones anymore anyway? Landlines. Apparently I do. All right, what was I saying? Okay, so we're going to talk about atoms and molecules in a bit, but right now let's talk about the symbols of the elements. You will see that the elements are either 2 letters or 1 letter. If the element has 2 letters, the first letter is uppercase, the second letter has to be lowercase. If the element has just 1 letter, it's always uppercase. For example, if you're talking about nitrogen, it's a capital N. If you're talking about chlorine, it's a capital C, lowercase l. If you're talking about sodium, capital N, lowercase a. You can see, all right? So the only way to get through chemistry is to begin to learn the symbols for the elements. You don't have to know all 118, but what I would like you to do is to know, like look, get your periodic table and know basically 1 through, they've got atomic numbers on the top. So you should know 1 through 36 super well. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, gallium, germanium, arsenic, selenium, bromine, and krypton. Those are elements 1 through 36. So you need to know the symbol and you need to know the name, okay? When you get to, so those are the first 4 rows of the periodic table. Then when you get to the 5th row, 6th row, 7th row, we can pick and choose some key ones. You should know number 37, which is rubidium. So I'm going to write down the numbers you should know. 37, 38, so rubidium and strontium. You should know, let's move along here. Silver is 47, cadmium 48, tin is 50. Okay, these are ones you should know. You should know antimony is 51, and iodine 53, xenon 54. All right, so that takes care of that 5th period or the 5th row. Out of the 6th row, you should probably know cesium, which is 55, and barium, 56. You should know lanthanum, 57, tungsten, 74, osmium, 76. And when I say no, I mean if I write OS, you should know that that is osmium. Or if I write osmium, you should know that OS is the symbol for osmium. Okay. Gold is 79 and mercury is 80. Lead is 82, 82. And bismuth is 83. Feels overwhelming. It's a lot. You've got a while before you need to know all of these, but start by getting some index cards, writing the symbol on one side, write the name on the other side. You don't need to worry about the numbers. You don't have to know the mass or the atomic number. And honestly, for every quiz, every test, you're going to have a periodic table in front of you. You know, it's all open book, open notes, periodic table. So you'll always have this, but you need to know the names and the symbols, just so that we can, once we start getting into higher level chapters, you've got the terminology. It's basically the alphabet of chemistry. So you don't know how to read unless you know the alphabet, and you really can't do chemistry unless you know the elements. Okay, guys? Let's see, where else are we? 83, and maybe 86, which is radon. That's that radon gas that you don't want in your basement. And then in the 7th row or 7th period, you should know number 87, which is francium. Radium is 88. What else should we do here? Seaborgium, let's go ahead and do seaborgium, which is 106, because Glenn Seaborg was from Michigan. It's pretty cool, from the UP. Seaborgium, what else should we do? And why not know, oh, uranium. Everybody has heard of uranium, so number 92, that's kind of down here. This is part of the 7th period, and this is part of the 6th period. We'll get into that later on in chapter 3 when we really start dissecting the periodic table. This is just a preview of things to come. And then let's know the last element, which is 118, oganesson. All right. So I've given you a few. Usually when it's not online, I ask my students to know more of them, but I think this is good enough. Okay. So key thing, if an element is one letter, it's one uppercase letter. If an element is 2 letters, it's an uppercase, lowercase. Okay? Do not, and I repeat, do not do this. Okay? Don't say, oh, this is my uppercase N. That doesn't work. Okay? You've got to have a proper uppercase N and then a proper lowercase, the second letter. All right. The elements that are most prevalent in the universe are hydrogen and helium. The elements that are most prevalent in the Earth's crust are silicon and oxygen. Notice uppercase, lowercase, uppercase, lowercase. Many of the elements have English names. Some of them have Latin names. Some are named after the person that discovered them. Some are named after the country where they were discovered. Some are named after the city where it was discovered. You know, lots of different ways that they name elements. Something like sodium, that is the Latin name, has this symbol. It comes from natrium, but the English name is sodium. See, this one over here is just nitrogen. This is named after the English name, but this one here is named after the Latin name. So once you start becoming familiar with the elements, then we'll be able to put them together as compounds. If you see something like this, you should immediately know that this is not an element. How do you know it's not an element? Because you have uppercase, uppercase. This means that this is a compound. If this was uppercase, lowercase, yep, that's an element. That happens to be the element cobalt. This is a compound carbon monoxide. Okay, so if I give you a bunch of symbols, you should be able to tell me if what I'm showing you is an element or a compound. If I have this, obviously, this is a compound because you have two different elements there. If I have something like this, compound, two different elements. This is not three elements. This is a Cl, chlorine, hydrogen. If you have this is fluorine, and I have two fluorines, and we're going to talk about diatomic, monoatomic, polyatomic, homoatomic, heteroatomic in the next video. But this over here is considered an element. Why? Because it's the same thing. You don't, in order for it to be a compound, you have to have two different elements, two or more different elements. Okay, and we'll practice with that. All right, in the next video, we'll introduce the terms atom and molecule, and then we'll get into the terms of homoatomic molecules, heteroatomic molecules, all that fun stuff. Okay, good.